3.7 again, more optimization. This time we're going to climb the ladder of difficulty a little bit, a little higher level application here. So what do we have? Open box. Let's see if I can draw this. Open box. Open box, if we're glancing at it, has all of these sides that all kind of exist in the bottom and all that kind of good stuff. We got all this craziness going on, and everything's shaded in, except there's no top. So the top is different. The top is kind of open up there. There's nothing on the top. So open box with a square base and a surface area of 108 square inches to have a maximum volume. So my primary equation is going to be volume, and we're trying to maximize it. So volume, let's see. So it's got a square base. I don't know what the dimensions are, but these are going to be the same because it's square. And I'd love to think that the third dimension is the same, but I doubt it is, so I'm going to call it h for height. So if I wanted the volume, I think I'm looking at x squared times h. There's my primary equation. My secondary equation is going to have to do with this surface area of 108 square inches. So my secondary would be my surface area being 108 square inches. So secondary, 108 for my surface area. And let's see, so how would you find surface area? Well, that thing's got, normally it would have 6 sides, top, bottom, left, right, front, back. Are any of them the same? Yes, 4 of them are. The front, the back, the left, and the right each have a dimension of x times h. Bottom is x, the side is h. The bottom is x squared, and remember there's only 5 sides this time. There's not a top. That top is open. So this time, to relate our variables together, I'm thinking we should take this h and we should isolate this h. So how about 108 minus x squared is equal to my 4x times h, and then my h, if I divide it, would be a 108 minus x squared divided by the quantity 4x. So there's my relation of variables. So now let's take this thing and let's put it in place of that h to make my new volume equation. So volume, x squared times the quantity, 108 minus x squared over 4x. And I guess if we wanted to, we could make this a little bit easier. Let's cancel some x's. I'm thinking when it goes in my calculator, it might be nice not to have to deal with all this. So let's cancel out this x on the bottom with this x on so one of these x's on the side. So 108 divided by 4, I think, is 27. Distribute the x. So how about 27x minus, that looks like an x, a 1/4 x cubed. So there's my equation that's going into my calculator. So 27x minus 1/4 x cubed. So let's go to my calculator again. And you know what else we should do before we get into this? Let's think this through really quick. X has to be positive. X can't be a negative number because it's a side. And the same way with h. So as I'm looking at this thing, I got to start thinking about how to make my graph a little easier to look at. So I know x has to be positive. So let's take this and let's move it over. And I'm also thinking that I'm graphing the difference between x and volume. So I think that volume is going to have to be positive also. So I'm going to kind of look at almost look at this quadrant 1 type thing. So let's put in an equation. So my equation is 27x minus 1/4 times x cubed. 27x minus 1/4 x cubed, and I hit enter. And there's my graph, and it's some crazy stuff going on. Holy cow. Now, when I look at this graph, let's see if I can do this. I'm not sure if I'll be able to or not, but I'd really like to just shrink this down. Wow, that's going way up there. So this graph that I actually have, I guess what I've just shown is there's got to be a maximum in between the 2 places that this function hits the x-axis. So I need to find that maximum. Well, how am I going to do that? Let's move this up out of the way. So I need to try to find this place where the function has a maximum. Well, the nice part about it is that this calculator will let me do that. So let's analyze this graph again. And if I analyze this graph, this time I'm looking for a maximum. So my minimum value, my lower bound, my upper bound. Look at that, it even resized my window for me. And I found that I now have a maximum value at the point 6,108. Well, what does that mean? Well, according to this equation that I wrote, this blue equation that you can see on the screen, I'm graphing the difference between x and volume. So the 6 is my x value, the 108 is my volume. So let's come back and look over here. So we're going to find this thing, this volume that I graphed, has a maximum at the point 6, 108. Does that answer my question? Well, I'm supposed to find the dimensions of the box. So if x equals 6, I need the h value to go with it. So this is my x, this is my v. I'm looking for the h to go with it. So let's take this 6 and let's bring this x value back over here. So what's the h that goes with it? 108 minus 36 divided by 24. So 108 minus 36 is 72. 72 divided by 24 says the h value under those conditions is 3. What's my dimensions of my box? My dimensions of my box are going to be 6 inches by 6 inches by 3 inches to take care of that problem. So there's a pretty good application of optimization. This other one, rectangular page contained 24 square inches of print. So let's make a picture, 24 square inches of print. So here's my page, and it says it's got margins on the top and bottom of 1.5 inches and on the side of 1 inch. So let's do this. So my picture is going to look something like that. We have 1.5 inches on the top and on the bottom. We have 1 inch on each side as far as the margins are concerned. So what do we know? It's got 24 square inches of print, which means this blue piece in here is 24 square inches. We're supposed to find the dimensions of the print, so we use the least paper. So let's see. Use the least amount of paper. Dimensions of print. I'm going to call this dimension x, and I'm going to call this dimension y. So my secondary equation would be the area of the print, which would be 24 square inches is equal to my x times my y. We're trying to use the least paper, so my primary would be the margins of the page. Well, this bottom dimension would be x in the middle with a margin with a 1 inch margin on each side. This dimension would have to be x plus 2. The vertical dimension would be a y in the middle plus a 1.5 on each side, so that vertical dimension would have to be a y plus a 3. So my primary equation that we're trying to minimize would be area again, and that minimum area would be the quantity x plus 2 being multiplied by y plus 3. X plus 2 times y plus 3. So, okay, relate your variables together. Let's say y is equal to 24 over an x. Let's take this and go over and relate our variables together. So my area equation, then I'm about to go to my calculator and graph. And yes, of course, I could multiply out those binomials. I could make a different equation. I'm just going to put it in exactly as it is, and I'm going to look for its lowest value. So let's take this. Let's go to my calculator again. Quantity x plus 2, quantity 24 over x plus 3. Let's go menu, and let's zoom this thing back to our standard window. And let's tab this thing, and let's have it, let's go through and create this equation. So I've got a couple of quantities here. So quantity x plus 2 multiplied by the quantity 24 divided by x plus 3, and hopefully my order of operations will work, and hit enter. So there's my graph. Now this is a little silly though, because I'm looking at these values, and these values are all to the left where all the x's are negative. Well, those x's can't be negative. Oh, what the heck does that mean? And we're looking for this thing to have a minimum value. I see a maximum. Well, none of what you can see in this blue picture is any good for us, because those are negative x values, and x can't be negative. In fact, as I'm looking at this graph, we should be over here somewhere. So what are we going to find? So here would be a quick suggestion that I would have. Let's do a quick menu and a graph trace maybe. Let's do a graph trace and see, oh look, there's my graph. That's what I've got. And if you wanted to shrink this this graph trace, I'm at 59.6 right here. When you look at these values, when x equals 7.8, my y value is 59.6, so no wonder I couldn't see it. It's up pretty high. So let's get out of that graph trace and let's do an analyze graph again, and let's do a minimum. Minimum value left bound, upper bound right there. It looks like I have a minimum at the point 4, x equals 4, and then my volume would be, or I'm sorry, my area would be 54. So x compared to volume 4 and 54. Jump back to your graph. What do we find? This thing has a minimum at the point 4, 54. But again, remember, the 4 is an x value, so it's my dimension of my print. The 54 is the area of my entire page. So this question was asked, what are the dimensions of the print? So we need to take this x value and take it back over here to find the y value that goes with it. 24 over 4 would tell me that my y dimension would end up being a 6. So my dimensions of print would be, what do we got there? We've got 4 inches by 6 inches. And then my dimensions of my page, which it didn't ask us to find, it asked us to find dimensions of the print. My dimensions of the page would be, let's see, so they add 2 to that x dimension, 6 inches by the y plus 3, 9 inches. So some people, depending on how they set their information up, come up with the 6 and 9 and think that they got it right, but that's the dimensions of the page. And the problem up here clearly asks us for what are the dimensions of the print. So another application of extrema.